Hello friends, how are you? I hope everyone is doing great. So today I'm going to talk about what is functional programming. Okay, so functional programming paradigm. So now most of the languages is converting uh, into like functional programming. So even like Java also is supporting like this functional programming features like function interfaces, lambda expressions and streams. Okay, so I would like to discuss about Java 8 futures. Before that, I would like to discuss what is the functional programming and what are the key concepts of this functional programming and what are the advantages and what are the disadvantages of this functional programming. So I'm going to discuss about that. Okay, so first of all, like what is functional programming? So functional programming is a programming paradigm so in which we try to bind everything in a pure mathematical functions or equations style. So it is a declarative type of programming style. Okay, so in functional programming, programs are constructed by composing and applying functions to a data, so that will emphasizing the immutability and the avoidance of side effects. So basically functional programming is way of writing code that focuses on using special kinds of functions. These functions are like mathematical functions or equations. They always gives the same answer for the same input, and they don't mess with anything else in the system. So the next one is, so what are the popular functional programming languages? So here we have a defined couple of popular programming languages. We have Haskell, Lisp, Erlang, C++, Kotlin, Perl, PHP, Python, Go language, Rust, Raku, Scala, Java. So Java is, since Java 8, it will support the functional programming language. So now, so I would like to discuss about what are the key concepts of the functional programming. So the first one is pure functions. What is pure functions basically? So pure functions is a functions that always produce the same output for the same input. So that has no side effects basically. So it does not modify the external variables or the data. So here I defined pure function as add here. So which will accept two input parameters a comma b and which will returns output as a plus b, right? So here the result will returns the 7. So the result is always 7, right? So there is no change. And the next one is immutability. So what is immutability? So immutability basically, once you define, right, so you can't change that data. So that's what I'm saying here. So you avoid changing the data after it's created. So instead you can create a new data structures with the desired changes. I just defined the numbers 1 2 3 4, and if I want to double it these numbers, I can make use this map method instead of modifying these numbers. So here I will get the double numbers set which does not impact the these numbers, so the numbers are remain same here. Okay, so that is immutability. And the third one is first class and higher order functions. So what is first class higher order functions? First class functions are treated as a first class variable. The first class variable can be passed to functions as a parameters. Okay, and that can be written from the functions. Okay, and that's what I mentioned as functions can be assigned to variables, passed as arguments and returned as values, right? And coming to like higher order functions, that are the functions that take other functions as arguments and they can also return the functions. Okay, here the example for Python. So here I have a higher order function, right? So this higher order function, uh, apply. So this apply higher order function, okay, taking two arguments, one is function, another one is value. So this is a function that will pass it as an argument apply. It represents the operation we want to perform on the value, right? So now the next, the second part of our code is this double function, right? So this double function take one argument as x, and it which will return like x into 2, right? So effectively doubling the value of x. So finally we have a result. So this result equal to apply double of 5, right? Apply with the double as the function argument and value as the 5 as the value argument. So inside this apply function, we have a function, it calls the function of value, right? So function of value which is translated to double of 5. So the double function is executed x set to 5, so that is 5 into 2 which is 10. So the result of double of 5 is assigned to result variable here, so the result is always become 10. So in the end the result containing the value is 10 because you applied the double function to the 5 here, right, using this apply higher order function. So this is like illustrates how higher order functions can be used to make your code more flexible by allowing your passing the functions as arguments to other functions, right? So here applies a one function which is allowing another double function here, right? So that is the higher order function. And the next one is referential transparency. What is the referential transparency? So expressions can be replaced with their values without changing the programming behavior. So here I take an example of this Haskell programming language. Okay, so you can specify, okay, so you can specify the type of function and its arguments using this colon notation here. So in this case I have defined a function called add, okay, that takes int as a integer, okay, arguments, these two arguments, and return the integer type, right? So the function simply adds the two arguments a comma b and together using this operator. And now let's look this. So here I have defined the variable called result, right? So within the type annotation, with a type annotation int, so it is indicating that the result is expecting the type is integer here. So to calculate the value of result here, okay, so that calculate the result here, basically you call the add function with 3 comma 4, right? So the add function is applied and it performs the addition resulting the 7 here. So this value is assigned to the result variable, right? So now how the referential transparency will come into the picture, let me explain. So referential transparency means so that you can replace an expression with its value without changing the programming behavior, right? So in this case the expression result is defined as add 3 comma 4, so which always know is 7, right? So you can replace this result with 7. So instead of add 3 comma 4, you can result equal to 7, you can define that like this. So with this 7, so throughout the programming without affecting its behavior, right? And for talking about recursion, so what is recursion? Basically recursion is a technique where a function calls itself to solve a problem. So here an example of a simple recursive function in a Python that calculates the factorial of number here, right? So the factorial function takes an integer as an argument, n as an argument, and returns the factorial of n here, right? So let me discuss in the base case of n equal to 0, the function is returns 1 here, right? So this because of the factorial of 0 is defined as 1 here. And in the recursive case, if n is greater than 0, right? So the n is greater than 0, function is calculate the factorial of n by multiplying n with the factorial of n minus 1. So this is done by making the recursive call to the factorial function with n minus 1 as the argument here, right? So to calculate this, basically for example, if you want to calculate factorial of 5, so how it will work? So factorial of 5 will calls factorial of 4 because 5 into, right, 5 into factorial of 4 is calculated again. uh, fa Again factorial of 4 calls factorial of 3 here, right? 4 minus 1 3 uh, is calculated. So this process continues until like factorial of 1 is reached because 1 into factorial of 0 is calculated. So factorial of 0 is returns 1, so that is base case. So this is like continuous regarding this factorial of 5, and the final result is I think 120, yeah, which is the factorial of 5. So this is the recursion is powerful and elegant way to the solve the problems. Now let's discuss about what are the advantages and disadvantages of this functional programming language. So the first one, the predictable and reliable. So functional code is easier to understand and debug because it relies on pure functions that produce the consistent results. And the next one is testing and debugging. So pure functions are easy to test, ensuring the code correctness. And debugging, basically issues are like isolated to specific functions or expressions. So simplifying the debugging, right? And if we're talking about the immutability avoiding like mutable data, right? That reduce the bugs and simplifies the code maintenance. And parallelism and concurrency, so functional code is well suited for like parallel and concurrent programming, that is making it efficient for modern hardware. And coming to like disadvantages, what are the disadvantages? We have performance overheads. Some functional programming languages, due to their emphasis on immutability and abstractions, that can introduce the performance overhead compared to like low level languages like C or C++. So while modern functional languages have made improvements comparatively like low level languages, okay, there can still be a trade-offs in the terms of execution speed and memory usage, right? And the next one is debugging complexity. Debugging functional code is especially when dealing with complex recursion or like higher order functions can be challenging. So stack traces may not um, provide as a much insight into that program state, right? That is a disadvantage. And coming to recursion overhead, so while you're using like recursion, right? So recursion is a powerful technique in a functional programming. So um, that is excessive use of recursion can lead stack overflow errors, right? So which can be difficult to handle. So um, these are the advantages and disadvantages of um, functional programming language, right? Okay, so that's it friends. I hope like I covered everything. So if you like this video, please go ahead and like. Okay, if you haven't subscribed my YouTube channel, go and subscribe my channel. So thanks for watching.